What it do, E-World? Crisscrossing Wires back with another short video. If you're ever replacing hall sensors, I've said this before. A lot of motors will come with this little PC board in them that has all three of the hall sensors connected to them. And normally these boards aren't really prone to being repaired. The traces that are on them are so thin that once you try to heat up these solder joints and remove the transistors from this board, I mean, if you're really careful, you can do it, but you may get away with replacing them one time, but I guarantee you, if you have to do it again, that board is not going to hold up. You know, those traces will start peeling off. And not only that, these boards are, they just put more potential for failure. So it's best to eliminate these PC boards and hardwire those transistors directly, like this, like I'm putting the wires to them. You know, these hall sensors are nothing but transistors. They're field effect transistors, so they react to magnetic fields. That's how it senses the position of the motor. Not only that, how fast the magnets are going past these field effect transistors. That's how it's able to calculate and determine the speed. But as I was saying, we're going to hardwire them all. So each transistor, there's three of them, obviously, for the different halls: yellow, green, and blue. So we have set three of them up. They all need 5 volts, ground, and whatever color sensor the hall is. Okay? So, also, you can't just solder the positive, the ground, and the sensor wire to any leg. It has to be the correct leg. There is an orientation when it comes to these transistors. Now, you may not be able to see it on camera, but one side of this transistor is flat. The other side has like beveled, slanted edges on it. That way you know the correct orientation. You know, there's a collector emitter base on these transistors, and if you got 5 volts going to the wrong leg, then obviously it's not going to send the right signal to your controller. So make sure the orientation is correct. You can kind of see it on camera, but when you get them in person, you'll be able to see what I'm talking about. So, you know, you're going to have the flat side facing one way and the beveled side facing the other way. And, you know, like I said, 5 volts has to be going to the right leg. So once you do that and put the leads on them, you can connect them to your phase wires the same way as you would with the PC board, you know, but just eliminating this PC board. So that's all we're doing. And they do tend to last a lot longer, and it's a lot easier if you have to replace them in the future. Make sure you use heat shrink on each of the legs to isolate them, because you can see I have the legs spread apart on that one, but normally the legs are really close together like that. The potential for them to short, if you don't have that insulation, the heat shrink in between them, it can definitely happen. So put some heat shrink on each of those legs and keep them isolated. And then when you mount them back in your motor, you can use some type of adhesive to keep them stationary. They fit pretty snug, but at least put some type of adhesive on there, and something that you can remove easily. You know, hot glue, silicone. They just don't put no crazy glue or super glue, something in there that's gonna have a hard time getting them out. But alright, y'all, that's it. I have videos on actually doing this step by step, but you know, this is just to show how it can be done without the PC board. Highly recommended. Alright, deuces. Okay, so this is what it looks like after we remove the PC board and hardwire our Hall sensors in. The main cause for destroying Hall sensors is heat. As you can see, just looking at this motor, these little nylon insulation strips are blackened and hard. They're crispy. They've been fried from how hot this motor has gotten. That can come from a lot of different things, just hard riding in, you know, in the summertime with too much power. Obviously, it's normally phase amps that destroy motors. You can run a lot of power, but as long as you keep the phase amps down, which is the current that actually goes through your motor to the coils, you can get away with higher power. But too many phase amps is going to cook the coils, and hopefully in this case they just gotten extremely hot, but they're still good. Hopefully, I won't know for sure until it's put back together. But as you can see, this motor has definitely been extremely hot, and heat is the killer of all electronic components for sure. Hall sensors, which are just basic transistors, field effect, they do not like high heat. So that is pretty much what killed these original ones, no doubt. So we hardwired them. We're gonna put them back in there and put some adhesive on them and secure them back in place, strap them down. As you can see, each one of those Hall sensors still gets its 5 volts, its ground, and whichever color phase wire was connected to it, yellow to yellow, blue to blue, green to green. And we do that to both sets of Hall sensors. You know, normally there's the main set, and then there's a reserve set in most motors. Some motors only have one single set. If you have a motor that has a reserve set, good for you. A lot of times guys destroy both of them. Once both of them are destroyed, then you got to replace them. Or if you just have one, then you know, once you destroy them the first time, you need to replace that one set. But if this motor, if the guy's lucky enough that this motor still works, what he should do is definitely turn his phase amps down, and these Hall sensors will last for a long time. But as you can see, that heat does a lot of damage. So yeah, all right guys, take it easy, take care. Crisscrossing wires, Hall sensor replacement once again. One more thing I want to add in this video that I didn't talk about. This is a temperature sensor. This is what temperature sensors look like. Really not a whole lot to them. It's 2 wires, as you can see. One leg goes to ground, the other leg goes to the sensor wire itself. As you can see there, that one's going to the sensor wire, the other one goes to ground. This temperature sensor actually got burned up. I mean, this motor got so hot, man. The little sensor part, as you can see right there, that's all it is. It's really small under there. It's got some silicone on it, and that thing just totally melted up. So we're going to replace that too. You can buy these anywhere you buy the hall sensors. You should be able to buy these temp sensors. All right, so luckily I had a few laying around.